Yeah, so welcome again. Today we are going to discuss about the secure software systems. So we need to understand that what it means by the secure, where we are saying that the secure software systems, we know what is a security, but here the concept is secure software system. So what we mean by the secure, with the first go, we can understand the secure, it means that any of the software we have, we wish to make it secure. But how? The normal means, the normal ways what we are using to apply the firewalls on our network is to secure software mean, or we are using the antiviruses, is the mean, or we are applying the different policies, is the mean that secure software, or this is something different, or we are applying the encryption techniques, algorithms, and different encryption techniques, mathematics to secure our networks and our traffic. So is the secure software system, or something else is actually the secure software system? So today we will discuss about that, to have a brainstorming to understand it, what it means by the secure, what it means by the secure software system, and how it is actually different from the general security concept, and how this is linked with the software development as well, and why this is important. And in case if suppose this is not important, then why we are here? And in case if suppose it's important, then how it's important? That is the goal of our today's lecture. So if you allow me, we just go to the second slide. So first of all, the first question we have to ask from ourselves, that does the security even matters? If we see in our real life, in our practical life, so we realize, yes, security really matters. Not only in computer, not only in a technology, but it really matters at our home. It really matters in our daily life. It really matters while we are traveling. It really matters while we are outside our home. So yes, security really matters for us. For example, one of the example here, we are going to the airport. So airport is increasing a security. So there are the different agents there. They try to use the scanners and scan our body. They try to scan our things, luggage and everything. So why they are doing this? They are doing this for the security of the airport. They are doing this for the security of themselves. They are doing this for the security for us as well. So in other words, we can say they are doing this to manage or maintain the security for everyone. So yes, security is highly important. So before we go ahead, if I just give you a small clip, an idea about that, in case if suppose they are using those scanners for the security purpose, those scanners are working actually under some software. What happened? If suppose there is a bug, there is an issue, there is a problem in the software, then probably it will not scan correctly, or it will be scanning, but the result what we are getting, it's not an accurate result. So what happened? This will bring the security issues for the airport, for the people, for us, and for everybody. So how the security breaches? There are so many people there. There are so many deployment there. There are so many eyes are there. They are looking there, everything. Okay, they are trying to manage everything using the gates and the scanners and everything. But a small bug in the code which is working actually for the scanner, if suppose that is not working correctly, it means the whole exercise and whole practice is not worthwhile. So this is giving us some indication that what it means by the secure software. We are not saying that we are done, but we are just trying to go with each of the slide that how secure software is important. Then we will realize that what it is, and then we conclude when we reach to the end. Now, discussion normally means takes away that the security is actually not a black and white. People will say, if we ask to someone, what's the security? So someone cannot say, this is a security. It's not a black and white. We need security at each step of our life. For example, just for your understanding, if one VIP has a movement, is coming to the one of the institute or organization, he has the guards in front with him and on his back, coming with a protocol. So it is giving him the sense of security, that he can protect his threat. Once he or she reaches to the organization, the guards are with him, as he is completely means being monitored by the security people, but now he is supposed to use the lift, elevator to reach to the top floor of that building. Now what happens if suppose building is 20 floor and any issue or any problem in the software happen which is running or controlling the lift, and what happened? Just because of that bug, the lift is going to be fall down from the 18th floor, 19th floor, or 20th floor. So what the security guards will do, how they will protect them. What the security people who are keep monitoring and cameras and everything, they will be able to do. Or any other kind of issue will come. What they will do if suppose something is happened based on the software. The same way, if suppose we took an example for the hospital, there are very critical, very critical applications in the hospitals, in the health. For example, the patients are under extra care in ICU, and we consider just nowadays the situation, they are on ventilator. So we are trying to manage everything. So we are not trying to manage everything manually, but we are controlling through the equipments and devices, and those devices are run through the software. Now, the one thing is that someone can come from the outside and disturb the software. This is also a security issue. The second thing is, say for example, if there is any physical failure of the electricity or something and system stop working, this is also some kind of security issue. Now what happened if suppose some hacker hacks intentionally and try to disturb or stop the means medical aid to the patient, the patient cannot survive. This is also a security issue. But now what happened, the software which is running, working, that software itself has any bug and it start malfunctioning. Again, we will lose the patient. So it means that is what? That is also something we need a security to make a software secure, to avoid the threat. So this is actually what we mean, that security, we cannot define it in a black and white. We just quoted a two examples from our real life. So you can see that we cannot say that the patient is in ICU, so it's secure. We cannot say that the patient, also the VIP is coming with the security, with high security, so it is safe, it is secure. No, but we can say that they are coming up covering up with the one aspect of the security. So from this, we learn that security has different aspects. And the aspect what we are trying to understand, that is the secure aspect of the software, not the external security, not the encryption security, not the communication security, not the network security, not the computer security, not the security which we can handle with the firewalls, not the security which we can handle with any other devices, not the security which we can handle with the physical security. But we are concerned here that how to make sure secure and safe the coding of the software, to stop particular software from malfunctioning. So I hope that you understand this specific aspect of the security of the software. And that is actually the secure software. And why we name it the secure software systems? Because any system, it uses the softwares. So systems built based on the softwares. So we are discussing for different systems. Like we quoted an example for the elevator, that's a system. Like we quoted an example for the ICU for the patient in nowadays current situation in COVID, that is actually a system. We can quote any example. Like suppose we are driving a car. Nowadays every car is, we say, computerized. It means it works unprogrammed. It's already programmed. What happened if suppose something went wrong? Then it will be a big issue. The thing which is for our safety, it can be converted into the danger as well. So protection, whenever we talk about protection, we have to keep this thing important in our mind. Protection is not in free. Protection is always demand the cost. So that's why we are saying that protection is always costly. In any other situation, either it is a physical security, either it is the encryption security, either it, whatever the type we discuss, security is costly. So in the same way, when we discuss about the secure systems, secure software systems, it is also costly. What it mean by the cost, we will discuss in our upcoming lectures, and we discuss it how it mean by the cost and how it increase the cost and production as well. The more secure or more security we require, the cost is directly proportional to this one. Because the personal security is a liberty and a privacy. So we have different threats. We have different vulnerabilities. So today is the right time we will learn about them. That how we eliminate the threats and how we control or eliminate the vulnerabilities. Because the vulnerabilities are actually inviting to the misexploitation. These are the points of exploitations. And these are being used by the threats. How they are linked with each other, how we can define, we will discuss it in our today's lecture. Now, further discussion in software engineering. That's what we were discussing in general. Now we're coming to the software engineering. So you remember that in the universities, wherever you're going, we are teaching you how to build the software. Is it or not? For sure. How to build the software. You need to go to collect the requirements, make sure your requirements are fine. You need to follow the SDLC process. You need to have testing. You need to have validation. You need to have follow-ups. You need to consider the coding standards. You need to blah, 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 blah. But the schools, the universities, we are not teaching you that how to breaking the software, but we are teaching you how to making the software. This is the most important point regarding the software engineering. And this is the most important point from where the secure software system starts. So How do you know that you have built a system? You write any system, any code, and segment that cannot be broken into. How do you even imagine? How do you even think? Cannot, because you are following the steps that this is the requirement, this is the SDLC process, and we fulfill the customer requirement. They were demanding this, so we means complete the software. And then they have the firewalls, they have the security mechanism, blah, 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 and we means install their software. If this is the way, then why the softwares are breaking every day? Why we are saying that there are the concerns and issues? You do remember we discussed previously, the user behavior is the most important thing, but the code is also a most important thing. How? You will learn in a couple of minutes now. And the vulnerability is what? Vulnerability is actually an informally bug which has the high security consequences. It means there is some weakness in your code which you didn't address it. It doesn't mean that your software has, while you're writing a code, it has an error. It does not having an error, even the syntax error or even the logical error. Because syntax error, for sure, it must not have, otherwise your system will not work. But even the logical error is not there. System is functioning properly. But still, there is a bug. There is a weakness. There is a gap. There is an issue in your software which can lead to the security consequences. How? What it could be? You will see the examples right now. This could be the bug in the code, or this bug would be in the flow of your system. What we mean by the flow, like suppose we have the systems, they have a sequence to perform. Like suppose elevator system, like suppose in our cars, like suppose in medical health applications, and anything, there is a sequence to be followed. And the other possibility that there could be a design flaws. You are designing, maybe there are a design flaw, or it could be a poor coding as well. Okay, so attacker can exploit the software and he or she can use that your vulnerability, that your weakness, that your gap to control your software. So they can use this for the malicious purposes. So you remember we just discussed about that we are going to the airport. They are saying, take your shoes off, and they are scanning and everything. That's a very small thing. We cannot compare that with the software security. Because if software security is happening, it may lead to the high damages. If they control the security and successfully board the passengers on the plane, what happens if any issue, any vulnerability, any bug in the software of the airplane, and when the plane is in air and it may start malfunctioning, or it may be under attack. So what happened? Where the security measures what was taken on the airport, what will be the benefit of that? So we may lose the airplane, we may lose the passengers, we may lose the everything. So the first steps of the security, they cannot help us. So this is why you remember we discussed and we said that security cannot be defined in black and white. So these are the different aspects of the security: physical security, software security, logical security. So security is not a black and white. Security starts with us, with our life, 24 hours with us. We need security while we are sleeping. We need security while we are walking. We need the security while we are going our office. We need a security while we're going back. We need a security while we are in market. We need a security at each and every step. So now what could be the vulnerabilities? Say for example, allowing easily guessed password if suppose you are the one who is writing a code and you didn't take care about these measures. So this could lead for the hackers to break your password. And once they break the password, now they have a complete control of your software. So in other words, maybe you have a complete lack of password when it is needed. This is a design flaw. Design flaw, what it means, like suppose for the some of the softwares we can discuss in the financial institution example. Say for example that we are having an access to the online to the Maybank or any other bank. We need to have the passwords and everything. Fine. We need the OTP and everything. Fine. Once we enter in the system, now what's the design flaw? The design flaw is, say for example, if we want to make a transaction to transfer some amount, that stage it must ask us again the means OTP or password or something. So if it is not required, so it means it is the flaw of the process or it is the flaw of the design as well. So you understand that what's the difference between the flaw of design and the flaw of the coding. I hope you know about the McGraw. The McGraw is a very popular publisher, very popular company for IT. They presented that the 50% of the coding mistakes and 50% of the design flaws are the reasons for the vulnerabilities. So you remember that there is a passive attack type. In that, what the hacker are doing, they are trying to monitor your traffic, reading your system, reading your information, decoding your traffic. So during that, they are actually trying to get the information about your software, about you, to reach to the vulnerabilities. They are pinpointing what are the vulnerabilities, what are the weaknesses, where they are. So later they can catch them. So this is how the vulnerability is. So in alternative definitions, you can just define it in your own words, or you can say an instance of a fault that violates an implicit or explicitly security policy. So it doesn't mean that this is mistake is intentionally being left by the software coder. No, because this is not the job of the software coder. The software coder will do the job for him what is given. That system is working, performance is 100%. Testing is okay, verification is okay, validation is okay. He is done with his job. That is the job for you who are the secure or security engineers. So once the code is ready, you have an equivalent share in developing a software. So you need to get the successful code of the software, and then you need to see that is there any flaw in the design, is there any flaw in the code, or is there any issue which can invite any vulnerability, which can invite any threat, which can be exploited by the hackers. So if there is something, then you are supposed to suggest to the coder that they can fix it up to make your software secure. I can give you one more example here. You notice that some of the time Facebook is hacked. I'm just trying to give you the giant companies example. Twitter is hacked. Sometimes the Chrome is hacked. So how it is hacked? Do you think that it is hacked by bypassing their firewalls, bypassing their security systems, bypassing their live alarming system and so many other things? No. It is hacked, maybe the left the vulnerabilities in their software. And this is a very important. You remember we say that this cost is higher if suppose we need a security. That is in different way the cost what we discussed. So you just imagine the people or a product is pursued in the market with its reputation. For a moment, if you just see that if you know that you are using one of the banking HBSC, or you are using Maybank, any bank, for example, for your online transactions. And once you know that these banks have the vulnerabilities and they are hacked for multiple time and their data is gone and the money is gone and everything is gone, then what happened? The company may fix it, but the company will lost the confidence of the customer. Once it lost means customer confidence and reputation, that will be a great loss for the company. This is the reason that maybe that company, the bank will means lost its business, maybe more than 50, 60%, or even maybe completely, because customer needs the security. So now the banks, they are providing all other securities, but suppose this type of issue is in software, then what happened to them? So this is how, this is something not important, but it's very important. So you need to understand that what it is. Now, what is the exploit and threat? I hope you understand, but more details on that. Exploit is actually a piece of a software, a chunk of a data, a weakness in your software, or a sequence of commands that takes advantage of a vulnerability. So again, it is linked with the vulnerability. So vulnerability is actually a weakness. So anyone who is a threat for us, they can come and exploit the vulnerability from our software. So they can do the malicious task using that vulnerability, not in a positive way, but they use it maliciously and they can bring the harm to our software. And that could be manually and that could be automated as well. This depends on a process. This depends on the vulnerability where it is. You remember we said that vulnerability possibly in design, possibility in a process, possibility in a coding. So this depends on where is the vulnerability. So it will be dealt by the hackers accordingly for their benefit. So this is how there are so many different ways so they can exploit the vulnerabilities. The threat is also because becoming a cause based on link on the vulnerability, but we have two meanings here, the two clear meanings here. The one is that is as an actor, the person, the hacker himself is a threat for our systems. So the source of danger, he is a source of danger, which is capable to violate what? Violate our confidentiality, our availability, our integrity, our information, our assets, our security policies, and anything which we want to secure. And how we can do that? Provided if suppose there is a gap, there is a vulnerability in our system. So then he can only be able to exploit it. Then he will be only able to become a threat for our organization or for us. Otherwise, no. So we may not have any vulnerability in our system. A class of exploits, for example, we call spoofing. Spoofing is actually one of the type of the attacks where it comes under the passive attacks. In passive attacks, what they are doing, they are actually trying to read the information from our system for our traffic, and they are doing everything, but they are not harming us at that time. So then why they are doing? They are trying to get the information, to gather the information, so later they can use it. So this comes under the spoofing. Now the next is we need to protect against the exploitations. If we find out there is the point of exploitation, because the vulnerability having a different level. Some vulnerabilities are very severe, some are very small, some are rare, it's ignorable. So if suppose they are among that range, then we can use the antivirus for them, like intrusion detection systems and firewalls and extra. They can control up to some certain level. And then we can protect against the threats. If we want to, we can use the forensic means. So I hope that you know about the forensic. If you don't know about the forensic, I can give you a basic idea. So in forensic, what we need to do, we try to find out the footprints. If suppose someone is trying to exploit any vulnerability in our system, who it is, from where it is. So based on the forensic, we can find out the culprit and then we try to punish him, or we try to reach him, or we try to not only punish him, but we try to safeguard for that particular vulnerability. So protection or protect against the vulnerabilities is, who is responsible? You are responsible as the engineer of the secure software. Secure engineer or security engineer or software secure engineer. This is the difference. So you need to understand that when you go to the giant companies, they will have different mechanism. They have a coders, they have a quality collection and requirements people, they have managers, they have security engineers, they have a group of people which can make the secure software. They have a group of people, they are there for the testing. They have a group of people, they are there for the validation. They have a people for the quality checks. So for the quality check, and they have a people for after deployment testing and so on. So they have so many different departments where they are building the software. Like suppose if we just give you an assignment, so you are working in a group. You are 3 in group, you are 4 in group. So you cannot follow all these steps. Because when we are making a professional software, so maybe we may have more than 10 to 15 only the departments, and in each department there are the different people, and each people, they are working with their own domain only. So then the softwares are coming out to us, and then the people are trusting on them, and then we consider that they are safe. So designing a software is not an easy job. So sorry. So this is how the secure software having an importance. So now again, we can see from here that the software security is not something which is easy. It's not an art. It's not like 1, 2, 3. But it seems in a different angle. We can call that like an arcane. Finding a severe vulnerabilities without source code, crafting the exploit position where they are. And there are endless clever ways to break the software. We need to, as a secure engineer, we need to know that what are the possibilities from where a software can be breached. So once we know that from where it can be breached, only then we can protect it. Only then we can suggest to the coder that how they can protect it. So you have a more knowledge, but the good thing is, the most important thing is that while you are building the software, you have 100% knowledge about your software. You know about design, you know about its testing, you know about its requirements, you know about its flow, you know about its coding. But hacker does not have this much information. Maybe he may have information in 10%, 20%, 30%. But you have more information. So you can know the loopholes about your software, and you can make it safe and secure. So don't just leave it to the experts that they take the responsibility, but the team who is building a software, including all those people, including you who are the secure software engineers, you have this job to take your responsibility to make it secure and safe. Now, some people, they might think that software security is a myth. No, it's not a myth. It is a reality. And you can find out the issues. You can find out, you just Google it, you will find out a lot of things. In previous days, there was the issue vulnerability with the Chrome. In previous days, there was the vulnerabilities in different of the operating system. Microsoft discontinued the different operating system. There was one of the operating system, so I just forget about its name, in the Windows series, Windows Me, I believe, Windows Me or something like that. So it was containing a lot of issues. So finally, they even installed it. So if we are lacking from these things, then The resulting is that we are not able to means continue with that software, and also we are not able to get the trust of the people. So this is the highly important thing. That's what we mean. We have to means take our responsibility and make it secure. Now, software security is actually, if suppose people start thinking what it has a future, okay, and maybe people start means fearing that how means we cannot tolerate it, or how these things can work. So this is very important. We have to plan well. We have to have risk management, which dictate that we deal in a means most probable way more than the possibility. What is the risk management? So you will learn in your upcoming lectures that what is the risk management, what are the risk models, so how we design a software, and once software is ready, so how we can see their flow, how we can check their coding, and I will share with you. You will learn in the upcoming classes. So you will find out that in hundreds and thousands, there are the different ways and the questions once software is going to be ready. So the security engineers are supposed to check it in that pattern and see that, make sure that the software before it's released, it's secure. Going ahead. So it's not a set of features like what you remember we discussed at the first slide. So we cannot say that security is in a black and white. It's not only a set of features, set of rule that only 1, 2, 3 go, and we just follow this one and then we say, no, this is software secure. It varies. It depends on the software to software. It depends on application to application. It depends that the software what we are designing, what type of it is. It depends that where the software will run. It will run on mobile, it will run on machine, it will run on server, it will run on a distributed system, it will run where. So these all factors are important to decide. Although we have a lot of tools and a lot of different experts, helpful people are there, okay, but when you see, when you write a program, when you learn, when you go ahead, so you will see that you can write your means code segment, and once you just go to check using the different tools, you will find that how many different vulnerabilities are in it, and you will be amazed. And you will do this in your lab sessions as well, and you will find, then you will even, it will open your eyes. Oh my God, suppose I'm just writing a segment of code which is the 10, 20 lines, and I feel that it is more safe, secure, but when I test it, when I run it, so I can find it out that there are a lot of the vulnerabilities and weaknesses in my software. So again, these things are there to protect us, to help us to protect, not protect us, but to help us to means protect up to a certain level. But again, there are the gaps. There are the ways we need to means follow, we need to consider. So you will learn in your upcoming classes, and you will do this practice as well in your lab sessions as well. So then you will be means able to see that how these things are different. So now you need to be careful as a security engineer. Like suppose even you are using any of the library, we mean a library from here, like most of the time you're doing the programming, you are using APIs. So you consider that this is, I'm using API from ABC, so this is safe. But how it is safe? Why it is safe? Could it be possibility that there are so many vulnerabilities in it? And sometimes the API you are using, it contains a lot of lines of the code, and it is not under your control. You cannot make changes in it, but once it is fit with your software, then you can see that how it would. So again, we will discuss these things, these all of the issues one by one, threat modeling, and these all of the things what we are referring today in our upcoming classes. And we will use the tools as well to see that how we can judge, how we can measure, how we can find out the issues in the software. And you will be amazed. While I'm sure that you are using so many you already done so many assignments, you submitted so many different codes, and so what you will do, you can just use the same segment of the code during this course, during this lab, and you will be amazed at how this is bringing the point of exploitations, how is pointing out, how is marking about the vulnerabilities and so many different things. So this will be with time, you will enjoy. This is a very interesting course as well. Now the next is that software security is not a problem for just the mathematicians. Most of the people, they think that the security means something which is concerned or are having a problem with the mathematicians. Mathematicians, why we say? Because in computers, we are using the cryptography. The cryptography is actually where we are using the different algorithms and encryption techniques to manage and maintain the security for the communication and for our softwares. So that cryptography is actually work at the back end, it's work with the mathematics. So don't you think like that this is enough? I hope that now you're pretty clear about that there are so many aspects of the security. So those mathematicians are not responsible, but the security engineers are actually responsible to consider and to see the things accordingly. So you have to prove access controls, rules, verifications, and so many other things. And you will learn in future as well in upcoming lectures. Now, software security is not a problem for just the networking and operating system. So what we are discussing, why we are discussing, just to give you a clear picture that you may not think that the software security is the issue or the something which must be addressed by the mathematicians. No, it is not by that. Our software security is a problem in operating system. No, it's not like that. You may just think that this is the problem of the networking. So the networking people, they can handle it. No, it's not like that. There is a security, but there's a different aspect of the security. They are responsible, but for something else. There is a security issues in operating system, but that is something else. They are responsible for something else. There is a security in mathematicians. They are responsible for something, but that something is different from secure software, what we are discussing. So that's why we are discussing that you have to understand that how it is different. Software had a security problems long before we had the internet. So don't you think even that these problems and these issues are once the internet is there? No, these problems are even having before internet as well. So now, reality that everyone must face not just the developers and the stakeholders. All the stakeholders means the users, the organizations, the companies, the developers, and everyone or any person who is involved in this cycle, they all are the stakeholders. So a learnable mindset for the software engineers is the ability to prevent the unintended functionality. As a security engineer, you are supposed to control that if suppose the unintended any functionality in the software is there, you are supposed to stop that. You are supposed to make sure that it is not being done. It is not going to be used as the point of weakness for your software. A point of weakness, what we mean is it may not be exploited as a vulnerability for your software. Now you can see from this example, this will bring you the things even more pretty clear for you. Let's see for this segment of the code, and this is a very simple few line code for the Java, where we are saying what we are doing a one kind of the transaction. So you can see, you can read that note below, which is we just put the underline as well. The user has no control over the price variable. So here, user does not have any control on the price variable. This example, what it is, it demonstrates a shopping interaction, okay, which is the user is free to specify the quantity of items to be purchased, and then a total will be calculated. So this is the segment of the code, just for your understanding, for your better understanding. So we just took one example. And this is written in Java. So now you just see here, you will not find any error, logical error, any syntax error. It is working fine. Okay. So this job is done by the developer. This job is done by the requirement collection people. This job is done by the testing people. This job is done by the quality people. This job is done by the validation people. This job will be done by the deployment people because they don't find any problem. But there is a problem. That problem is for the security engineer. You as a security engineer, you need to pinpoint that point. And then you need to guide to the coder that there is an issue. They have to address that. So what's the issue? If we just start reading the last lines below the picture, the user has a no control over the price variable. However, the code does not prevent a negative value. So in this, with the help of the code, the coder is the only one who need to write the extra line of the code to prevent the negative value. So because in this code, at this moment, negative value is not prevented. So then what happened? Negative value from being specified for the quantity. So there is means no mechanism here. They didn't handle this one. So if an attacker were to provide a negative value, then the user would have their account credited instead of debited. So if the user or the hacker is trying to use the negative value, so he will get the product as well. And also at the same time, he will be able to get the money back to his account. Or at least he will not be, he will be able that he is not supposed to pay anything for this. So this error is because of the code. This aspect is actually making this code of the software as weak, or this is the not handling negative value is actually that is the point of vulnerability. And that could be exploited by the hacker. So hacker, what he will do during this passive attack type, he will try to get access and he will try to see, he will monitor your traffic, he will read the code, and he will find out, oh, this is the point of exploitation. So now this will become a very easy thing for him. So he can play with your software. So now what happened is, suppose this thing has happened, so you just now think in a big scenario. So this will bring a very big issues for the organization, for the online system, for your company, for the organizations, for the customers, and for everyone. And when this point is going to be publicly announced, then what happened? The people will not trust on your application. The people will lose the trust not on your application, but they will lose trust on the company. So the company will be in loss. So just see how much cost it will be bear just because of this line of code. So why I'm sharing this code with you, to give you a right and a proper understanding that what we mean by the secure software. So I'm repeating here, as a security engineer, you are not supposed to write the code. This is not your job. So don't you expect that you will be the one who will write the code. The code is the responsibility of the coder. Your responsibility is to examine the code, monitor the code, and find out if suppose there is any vulnerability or there is any point of exploitation, there is any possible threat can be come up in near future. So you need to make sure and lock that part. So now you can advise to the coder that this is a weakness in this code, so please address this. So coder can address it, and then it means that you are safe from this point of exploitation. Now there is a mainly he's a very big name in the secure software system, and this presentation is also dedicated to him, so you can see his name in the footer. What he's saying about, for your better understanding, saying that we are discovering that software we develop must be secure. How? Through this experience, we have come to this value. Vulnerability prevention is how we can over the exploit avoidance. So we need to make sure that how we can prevent the vulnerability. So it cannot be there may not be it exploited by the hackers or by any person later on. We need to have The developer responsibility is what? They must be having the expert reliance. Risk management, they have to have a very comprehensive plan for that. Secure software, like you people, must have over the security software. And engineering knowledge, they must be clever to use the different tools. So what he mean? We can make a more software safe, like those people who are responsible for vulnerability protection, they have to take their responsibility. Developer has to take their responsibility. Risk management people, they have to take their responsibility. And secure software, they have to take their responsibility. And engineering knowledge people, they have to take their responsibility. This is only the crust. Means this is not the whole thing, that like what we were discussing. So for example, if we say there is a line of code, only 100 line of code, again, these all departments are supposed to take their fully responsibility to make it done, to make it sure about their part. Then only we can say that our software is secure. So this is very important. While we are going to design a software, it is coming to in our hands. It's safe. It means there are so many different people, groups, they are working. They are looking for the different aspects. Then it only comes to us. If we are using some software which is going to be failed, we cannot blame to the one, but you can see that how many people are involved. Then we see that which one, it means which one step was not taken care carefully. That's why there is a problem. Now, secure software development life cycle. After understanding the security, after understanding their role, after understanding these all things, just give you a basic idea about these things. Now we're again coming back to the SDLC. So the question is that why we are coming to the SDLC? The answer is because we are here to make sure the software will be secure. To make the software secure, we need to follow each step of the software while it is going for the design. So in the software design, you know, as a software engineers, that SDLC is a backbone. That any software, for any software, every team has to follow the SDLC, all of the steps of the SDLC. So as a security engineer, we have to follow the same SDLC, but not as the software engineers are following. They are following in their aspect. We are supposed to follow in our aspect. What is our aspect? Our aspect is that we need to make sure that each step of the SDLC is also secure. What the requirements they are collecting, the requirements are also secure. So now this is a very interesting thing. So you may have a question in your mind, how come the requirement could be secure? For example, you are collecting the requirements. So the user are the organization people who are demanding for the software, they are not technical guys. They are not security engineers. Whatever they feel in their mind, they will ask to you, we need this, we need this, we need this, we need this, we need this. Sometime intentionally, sometime unintentionally, they provide some requirements, and those requirements maybe lead to the vulnerability, maybe lead to the point of exploitation, maybe lead to the threats, and maybe become a cause for the failure of the system. So the coder people are the requirement collection people. They are doing at this stage of the SDLC, they are actually collecting this information, but they don't know that this will be harmful or whatever it is. But you know, as a security engineer, you know clearly that this requirement is not doable, not addressable, cannot be part of the software. So then you can block that requirement. No, this we cannot go. This we can go. This we can go, but in this way, not in this way. So this is what we mean, that you need to follow the SDLC from all of the steps, starting from the first step to the last step, so you can know that how it can be done, okay, and how all of the steps are becoming secure. So now you can see from here that actually what are the concerns? It's not a single concern. It's not a one concern. So we have ubiquitous concerns because we say that security cannot be black and white. It cannot be defined in one word. So you can make a security mistakes at any step, at every step of the development of the life cycle. That's what we were discussing. So you need to be very much careful about all of these steps of the security means SDLC. Requirements that allow for privacy violation. Okay, for example, the secretary can view everyone's patient's record. This is as an example. So you need to see, is it okay or not? Can you edit or not? Introducing a design flaws, maybe giving a plugins to total access. Maybe we are just providing a plugin, they are demanding to add a few of the plugins and they can take us to the complete software access. No, we cannot. Okay, maybe in the code level, there are the vulnerabilities like separate buffer overflow, and there are the other means type of the issues. So we cannot allow them. Missing a vulnerability in code, inspecting and testing, and introducing a vulnerability by regression and maintenance. So you are responsible to see all of the steps, introduction of stacks, means coding level, requirement level, designing level, testing level, validation level, deployment level. So you need to make sure that the software is going secure and passing all the stages. So in the giant companies, until the means you can see now the means you are the one who need to facilitate the secure deployment as well. So in the giant companies, until and unless the security engineer will not give the certificate, they will not move to the next phase. This is very mandatory. So if they move to the next phase, that will be considered as null and void because the software will be failed once it will be launched. So now you can see from here, this is your SDLC, starting from requirement and going to up to the after the deployment to the maintenance. So these are the few of the tasks we try to pinpoint here for your better understanding. So you need to see that in requirement and planning phase, maybe there are some means abusive cases. Maybe the risk assessment, you need to do the risk assessment. You need to do the threat modeling at that stage. That maybe the requirements which are coming, the requirement itself, they have a problem. If you don't monitor at this stage, what happens? The coder will means done with the program will start working and those will be addressed. And remember, this is very costly. Costly in a means as a security engineer, if you miss at one stage, now even the software is ready, not deployed, but someone pinpointed this was an error at this stage. Now you cannot go back. If you go back, the cost will involve a lot. So your job is very critical. So you will learn in our upcoming means lectures. So you will see that how the cost is involved. The cost is involved in multi ways. So a small mistake we will means discuss with you the different case studies, even though they are the previous case study, because we need a previous case studies where the security engineers, the coders, they make a mistake. So then how much cost was involved? Sometimes the cost goes to the double. So you are supposed to see for all of these steps, requirement, design, implementation, testing, deployment, and even up to the maintenance, you need to make sure about this. Now, what are the core security processes? You know, whenever we talk about the security, we always talk about the CIA. CIA is actually the confidentiality, integrity, and availability. So you need to make sure that your software security breaks into these categories. The one what you are producing, it provide, maintain the confidentiality, it provide, maintain the integrity and availability in a very broad spectrum. Okay. Some people add in auditability and integrity. So your software should be auditable. Your software should be trustable. Your software should be available as well. Now you can see for the confidentiality, we may go with little speed because this is very common concept. And I have another class as well at 2 o'clock, but not means very fast in case it's supposed to, your understanding is important. With a few slides to the left, we can continue in the next session. So in this, the system must not disclose in confidentiality any information. What we mean by the confidentiality, that the information is highly secure. It must not be disclosed, okay? And intend to be hidden. For example, your credit card information on the website. So your system should be like in a way that your bank account, your credit card, and other information may not be disclosed. Otherwise, it can be misused. And in open source softwares can still be confidential. Even if we have the open source softwares, it must be confidential. Integrity. System must not allow the means assets to be changed or altered, any alteration or any modification in it. The integrity of the system, the integrity of the data, integrity of the contents should be there. And it may not be disturbed by the unauthorized people. So we must be able, then only the people can trust our system. So the data being stored, data being functionality, the process at each step, we have to make sure that we are following the CIA. Now, availability is another important point. Not only the security, we make secure, we make integrity intact, we make confidentiality intact. But what happens when the software is required, when the data is required, and it is not available at that time? So then again, this means cannot be recommended. So availability is a highly important aspect. System must be available when it is needed. So these are the extremely means hard. We need to consider these things to make sure that our software and things are means intact. Security policy information is something else, which is known as the ISP, Information Security Policy, which is highly important as well. That is actually to make sure that there are the set of the rules that how software is being used, how things can be used, what are the procedures and policies the organization or the user has to follow. So this helps us to implement our security policies. Security requirements. A security requirement is the security features required by the system or user. So how they need to take care while they are using our system. So security requirements are considered as a non-functional requirement. I hope you understand as a software engineer, what are the functional requirements and non-functional requirements. These are non-functional requirements, but they are very important as well at the same time. Identification and authentication is another important aspect. We have to identify. We have to authenticate. What do we mean by the identification and authentication? If we are sending something to Mr. A, we have to verify first that the person who is receiving this data, that is Mr. A in really. Maybe there is a person, Mr. B, and we are taking care about the CIA, but we are missing this thing, then we will be in trouble. So this is the means on top of the other things, that's what we discuss. Then there are the other miscellaneous philosophies and proverbs about this means software security. So we can say the defense in depth, we need to find out means anybody can break our software, how we can break our software. And we need to think that how we can protect it. So these are the means more what we can call the proverbs about security. Like what we are saying here, if they break into this, they can't get any further. So we have to have a mechanism while we are handling. If someone, even though we are following these all standards, is able to break our software and they are into our software, again there should be a barriers. It cannot be goes to the some certain levels. This is the most important points. So think about the middle age castles. So like suppose in this way, we must have some phases and channels as well. Okay, so this is the most important and means aspects that we need to think about that. And the other thing is about we may not give, like suppose at the time of the requirement collection, they are saying our manager or sub manager or ABC employee, he needs the privileges. So we may not give the all privileges. Okay, we have to give the privileges, right privileges to the right persons only. That what are the right privileges to the right persons. So because sometimes we give the more privileges, it also can bring the issues for us. And we need to consider as a security engineer to fail also securely. What it means is something very strange, but it's not any strange. In case we are taking all the aspects of the security, but probably any other point which we were not able to means look on it, and our software is means due to any vulnerability is means compromised, then in case if the software is going to be fail, then also it need to fail in a secure way. Means while it is failing, it may not give all of the secrecy, all of the information to the hacker. It may stop working, but it may not go to the means with all of the options in the complete entire data to the hacker. Because we can come up, we can grow up, we can address the issues, and we can bring software again, means update in live. So if all the things are gone, then it will be hard for us to means bring it online again. Now, detect and record. As a security engineer, we have to have a mechanism where we means keep detecting a runtime, keep monitoring runtime to our softwares, and see that what issues are coming, what things are coming. Before our success is, before any point of exploitation vulnerability is being pointed out by the hacker, before that it's better that it may be pinpointed by ourselves so we can protect it. So this is how the way we need to means think on that. Secure by default. Don't rely on your users that you think that they are means correct, and they will be using it in a simple way, and they will be using it in a secure way. No, cannot. We cannot trust on the users. So we have to have this thing. How we can handle this thing? We can handle through the policies. That's what we discussed a few minutes before. We can discuss that through the policies, that how we can come up with the policies where we can make sure that our system is being used securely. Now, this is all about today. I hope that you understand about the secure software now clearly, and now you also understand the importance, sorry, the importance of the secure software system. Because most of the time, the students, they don't understand, they don't understand the clear difference between secure software and computer network security, or wireless security, or the intrusion detection, or the other security concepts. So now I hope that after this lecture, you will be able to understand clearly that what we mean actually by the secure software system. And now we will continue in our upcoming classes. So you can see that now we are discussing about the threat modeling, what's the threat modeling, how we can do, how we can plan, and how we can collect the requirements, and how we can see for the each step of the SDLC, and what is our job, and the rest of the things. So it's a very important and very interesting course. And as I discussed in the middle, that the moment you will start doing in your labs up to 2-3 labs, because it is just your start. So after 2-3 labs, you will be going to in depth. So you will see that how you are using the tools and finding out the vulnerabilities and issues. And then you will be amazed that the thing what you consider is safe, and this thing is having a lot of issues. So you will find it, and also you will have the assessments. In those assessments, also simply you will take the different softwares. Maybe you will pinpoint to the time system from the tailors. You can pinpoint any running system, and then you will just go to check about its vulnerabilities. And then your eyes will be really, really open, because you will find not in 1 and 2, but you will find in 100 and sometimes in 1,000 different vulnerabilities. So you will see, then you will realize that how much these things are secure, and why the people are trusting, and how the people are trusting. So then you will realize the actual mean of this one. So thank you very much for your attention. I hope that you understand the things very well. So in case if suppose you have a question, please let me know. And if suppose you don't have a question, then we can go for the attendance. I believe 1, 2, 3, 4, 5, 6. So you all are present. 100% are present. Is it? 1, 2, 3, 4, 5, 6. Yeah, you are 100% present. Yeah. So you have any question? Please let me know. Yeah. Any
No.
question? Yeah, that's great. I hope you understand the things.
Yes, sir.
That would be great. That would be great. I wish that soon this MCO will be over and we will have a chance to face, because then you will be having a even more uh, good chance to means discuss and can show you the more examples as well. So anyhow, wish you best of luck, and then I'll see you to the next lab. So now we are
Uh,
just stopping the recording. Uh,
Sir.
yes, please.
Yeah, I made a mistake of like submitting the wrong link for the lab
Mhm.
yesterday. Is it okay if I submit it today? Because it's a bit late when I noticed I submit the wrong link.
No problem. You can, because you already mentioned to me this is happening because it is the start. So until you will go in a flow, so this thing is normal. So not to be worried. So you can submit it right now, and you just make a one-line email to me that this happened. You submitted to the wrong link. So when the moment I will check it, so I will have in my mind. Not to be
Yeah,
worried.
I
Okay.
already emailed you. Yeah.
Yeah, that's great. That's great. So you can submit.
All right, right. Thank you, sir.
Okay, you're welcome. You're welcome. So wish you all best of luck and see you in the next lab session. And thank you very much for your attention. And I hope that you enjoyed it. Bye.